So, I promise, y'all, we're gonna slow down a little bit. We're gonna make sure that you're ready because next Tuesday you have a quiz. So less than a week. Wednesday, Thursday, Friday, you just spilled stuff on yourself. Wednesday, Thursday, Friday, new lessons. Monday is a review. Tuesday is a quiz. Okay? So get your calculators. When we are multiplying fractions, first off, if we have parentheses and another parenthesis right next to it, it means multiplication. So I am taking the 6, the 2, and the 1. Now, immediately looking at this, I have how many negatives? 2. So does that mean it's going to be even? Let me try that again. Is it going to be negative or positive if I have an even number of negatives? Positive. Okay? So I'm done with the negatives. So I'm going to do in my calculator 6 multiplied by 2 multiplied by 1. I press enter. I get 12. Then I have to do the same thing for the what? What are these called? What's the bottom number of a fraction called? Denominator. So I do 14 multiplied by 8 multiplied by 10. And I'll make sure that I put those little dots there so we know we're multiplying. So 14 multiplied by 18 multiplied by 10. Oh man, 2,520. I showed you yesterday how to do these. So get your calculator. Do 12 divided by 25, 20. And I get a decimal. I know that yours goes straight to a fraction. Is that correct, Isaac?
Yeah.
Okay. But the rest of ours don't. We have 0.004761,905. Is that correct? Yes? 12 divided by 22, 25. So you have it backwards. So the numerator always goes in first. Yep, divided by. Okay, so in my calculator here, I press second PRB. That's where the FD is. So I press second PRB. Yours is going to town. Yours is second table. Nope, so clear. So yours is second. You need to find the fraction decimal. Press enter. Okay. You know how to use yours? So, for this one, this all becomes 1 divided by 210. That's the simplified fraction. Everybody with me there? Did I lose anybody? Okay. These are a review from yesterday. And listen, I didn't expect you to really get them great. But go to your notes from yesterday. So go to your notes. We talked about 3 properties. Okay? We talked about the product property, the quotient property, and the power property. This product means what? What's product? Do you know? What does the word product mean in math? What do you think?
The answer.
To what?
To a multiplication.
Ah, product is the answer to a multiplication problem, right? Okay? Answer to the multiplication problem. The product property says that if we are multiplying things with a like base, the base is what? What's my base here? Somebody other than Alec. What are my bases in number 2? X. I have an X, I have an X, I have an X, which means my answer is going to have an X. When we multiply like bases, we do what with the exponents? What's that? What does the rule say? We keep the base and, so if you're looking at your notes, what does the power product or the power property say? We keep the base and we, that's the quotient property. Yep, you're all right. Not multiply, that's the power. This is the product property. Add the exponents. 3 plus 8 is 11. 11 plus 5 is 16. And you might say, Mr. H, why? Why are we adding them? Okay, so I'm going to do this. X, X, X. That's what x to the third is. The 5. 1, 2, 3, 4, 5. Oh, 6, 7, 8. Now the 5. 1, 2, 3, 4, 5. Shoo! Okay? Does everybody see this? This is really what let me try this again. Expanded form, there it is, of exponents is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12, 13, 14, 15, 16. Oh. Could you always expand it out? Yes. Do you want to do that every time and count them? No. Which is why we know when we're multiplying like bases, we can keep the base and add the exponents, because that's what it really is meaning. Questions there. So I get x to the 16th. This is the quotient rule. The quotient rule says, keep the base, subtract the exponents. Do we have like bases? We have an x and we have an x. We have a y, we have a y. So the x's are like bases, the y's are like bases. Where's my larger x, in the numerator or denominator? Numerator. So that's where the base is going to stay. And it says to subtract the exponents. What is 18 minus 9? 9. Where's the larger y? Numerator or denominator? What do we subtract? Somebody else. Kendall, do you know what numbers we're going to subtract for the y?
9 minus 8.
Not 9 and 8, so those were the x's. What are we going to do for the y's?
4.
Yeah, so we're going to take the bigger number, 8, minus 4, and that gives me y to the 4th. Okay? I know that we kind of rushed through this yesterday. Today is the day to get caught up on it. If you didn't copy this down, if you missed it, you need to. Okay? Questions on the warm-up. Mr. H, I have a question. Yeah, what's up? Will I see questions like this on my quiz? You mean the one on next Tuesday? The one that's Wednesday, Thursday, Friday, Saturday, Sunday. Monday is a review day. Tuesday in 7 days? Yes. You will see questions like this on your quiz on Tuesday. Oh, Tuesday of next week? Yes. Tuesday of next week. Everybody with me? Okay. So, let's do a little review. Is everybody good with that? Okay. So we are doing exponents day 2, and then you're going to have some time to work. Your homework should be watching a video today. Because it's Wednesday, and I don't want to give you too much homework, because that's what we do on Wednesdays, right? So this is exponents day 2. So I would write this down. Make sure you have it. We're going to review. I'm going to drill this into your head. So, first thing we need to know. We talked about this yesterday. Everything has an exponent. An example, 7x to the 8th. There are 2 bases there. What are the 2 bases? 7 and x. 7 is a base, x is a base. Which of those bases does not have an exponent?
7.
The 7. If you don't see an exponent, what is it? If you don't see the exponent, what does it have to be? It's a number. It's a small number. Isaac, do you know?
Why is it like? Is it just? Oh, are you just like having the x in between, or is it like 7?
What's the power with the 7? What's the power with 7? There's not 1 shown.
Oh, it's always 1.
It's always 1. You need to understand that if you see 7x to the 8th, that's really 7 to the 1st, x to the 8th. Okay, so if you do not see a power, that power is 1. Listen again, if you do not see a power, the power is 1. And you're like, Mr. Rich, we haven't gone over the homework. I know. Number 2, we have the power, not the power, the product property. Okay, which says x to the 6th multiplied by x to the 12th is x to the 6 plus 12, which is x to the 18th. Okay, I'm just going to give you a couple examples. So there's an example. Here's another example. 3 to the 3rd, x to the 2nd, times 3 to the 9th, x. Okay? Looking at this example, what do we need to put? Looking at that example, what doesn't have an exponent? So, which x? First x or second x?
Second.
The second x doesn't have an exponent, so we're going to put it in there for it. Boop. Do we have like bases? What? The 3's. So let's just start with the 3's. So that keeps the base, 3 plus 9. What other base do we have that's the same?
What about the 2?
So we're not worried about these numbers, we're worried about the bases. So what bases? The x's are the same. So that gives me x. Then when the base is the same, we add 2 plus 1. So that's going to give me 3 to the 12th, x to the 3rd. Okay, could we simplify that more? Sure. You could do 3 to the 12th power. Anytime that you have a number, not a variable, you could simplify it. Have I lost anybody yet? Oh man, can we see all that? I don't even know if we can see all that. Barely. There we go. Okay, still good. So that's the product property. Then we have the quotient property. This example is going to start off x to the 8th divided by x to the 3rd. Okay, if I'm writing it down, you want to write it down. Whether you think, oh man, I got this or not, hey, we're going to keep doing practice. Listen, I boxed professionally for years. And guess what I did? I practiced. Jesus went out and preached to his disciples. And then they were scared when he was crucified. They were in the room. The Holy Spirit came over them. And they went out, and guess what? They practiced preaching over and over and over. Some of them died for doing this. But they still made it a point to do it over and over and over to reach their goal. Same idea with what we're doing. So, I don't like seeing it like this. I would suggest if you see a division problem that's horizontal, change it to vertical. So x to the 8th divided by x to the 3rd. The product property says find the bigger x. Where's it at? Top or bottom? Top. So I'm going to leave the fraction. I'm going to keep the x. And I do the number, the exponents, subtracting. Well, Mr. H, what goes in the bottom then? A 1. Because we want all the x's in the same place. So this gives me x 8 minus 3 is x to the 5th divided by 1. What's 7 divided by 1? Use your calculator. What's 7 divided by 1? 7. What's anything divided by 1? Anything, right? So x to the 5th divided by 1 is x to the 5th. Everybody with me? Have I lost anybody yet? Okay. Then we had another one. We had the power property. Let's say we've got z to the 5th all to the 4th. So we have a power raised to another power. What we do here is we multiply the exponents. We take the 4 and we multiply it to the 5. So it's really z 5 times 4, which is z to the 20th. Did I lose anybody there? Okay. Is this all starting to, I mean, we did all this yesterday. It should be like, oh, okay. Now I'm starting to see it. Rule number 5. Any number that is not 0 with And exponent of 0 is 1. As soon as you see something like this, 128 to the 0 power. Immediately, 128 to the 0 power is what?
128.
No.
Oh, 0.
Any number that is not 0 with an exponent of 0 is 1. That's it. So what if I see something like this? B to the 0. It'd be 1. Last but not least, negative exponents. Flip them. Okay? Negative exponents. Flip them. Mr. H, what do you mean? Well, if we have x to the negative 3, the first thing I want you to do is make it a fraction. As soon as you see a negative exponent, if there is not a fraction, make it a fraction. Everything can have a denominator of 1. The base x has a negative 3, which means all of this, just the thing with the negative exponent, gets flipped. If it's in the top, where would it go?
Bottom.
The bottom. So, right now, it's x to the, and when we flip it, it becomes positive. The goal is to make it positive.
Where'd the 1 come from?
Because we can divide anything by 1. So, anything can have a denominator of 1. So x to the third. Well, what's in the numerator? Well, there's nothing left, but there is. Just a 1. This one doesn't go up. It's just a 1. Because I can always have just a 1 there. Okay? What do you mean, Mr. H? Let's do one more. Well, let's try this. This is going to be a little bit trickier. Let's go x to the negative 9th divided by y to the negative 4th. It's already a fraction. Does everybody see that? Okay, so I don't need to divide it by 1 this time. But we've got negative exponents. So where does this x to the negative 9th go?
Bottom.
Okay, and becomes
X 9, yeah.
x to the positive 9th. Well, what else has to happen?
Y.
Negative 4 goes where?
Top.
To the top and becomes?
Positive.
So it's y to the positive. Questions? Okay, so here's what I want you to do. You are going to double check your work. You did 2 through 10. Okay? Double check your work right now. 2, 3, and 4. Listen, 2, 3, and 4, all you're supposed to do is match them to the things. So open your book to page 21. You're doing 2 through 10 again. You should have already done it. You told me you guys already did it, right? So that's what we're working on right now. Questions?
Wait, so we just do it again?
No, you're checking your work. So now that you've seen it again, you might look through it, and I'm only going to give you like 3 minutes. But just double check to make sure that you're like, oh, okay, maybe this one's wrong. Oh, I saw a negative, but I did something different. Does that make sense? Okay, go ahead.